We are going to learn about rationalizing denominators. Now, what does rationalizing a denominator mean? This means that we have a radical in the denominator that we want to get rid of. We are fine with radicals in the numerator, but we are not fine with radicals in the denominator. Let's do some examples. Let's say we have the fraction 3 over the square root of 5. Here, we have a radical in the denominator, which we do not want. So, we're going to rationalize it. The first step is to multiply by radical 5 in the denominator and multiply by radical 5 in the numerator. This makes sense because any number divided by the same number is 1. 3 divided by 3 is 1. 10 divided by 10 is 1. 1,300 divided by 1,300 is 1. Negative 12 divided by negative 12 is 1. Same way, radical 5 divided by radical 5 is 1. We're technically just multiplying 3 divided by the square root of 5 by 1, and anything multiplied by 1 is itself. 3 over 4 times 1 equals 3 over 4. Negative 5 over 6 times 1 equals negative 5 over 6. Same way, 3 divided by the square root of 5 times radical 5 over radical 5, or times 1, equals 3 divided by the square root of 5. We are not changing the value of 3 over the square root of 5 in any way. Now, once we multiply by radical 5 over radical 5, we get 3 root 5 over 5, because radical 5 times radical 5 is 5. We rationalize our denominator when there is no radical in it. Since there is no radical in our denominator anymore, we have rationalized it. So our answer is 3 radical 5 over 5. Let's try another example. Let's say we have the fraction 7 over 10 to the power 1/2. You might be thinking that there's nothing to rationalize, since the denominator doesn't have a radical. However, 10 to the 1/2 power equals the square root of 10. Remember, x to the m over n power equals x radical n to the whole thing to the m power. For example, 5 to the 3/4 power is the same thing as 5 radical 4 and the whole thing to the 3rd power. 6 to the 9/10 power is the same thing as 6 radical 10, the whole thing to the 9th power. Same way, 10 to the 1/2 power equals 10 radical 2, the whole thing to the 1st power, which is 10 radical 2, which is just equal to the square root of 10. Therefore, we can rewrite the fraction as 7 over square root of 10. Then, we multiply by the square root of 10 on the numerator and denominator. Then, we get our answer to be 7 multiplied by the square root of 10 over 10. If you are confused about the x to the m over n power, let's try this problem a different way such that we don't need to convert 10 to the 1/2 to a radical. So we have the fraction 7 over 10 to the 1/2 power. If I multiply 10 to the 1/2 power in the numerator and denominator, I get 7 multiplied by 10 to the 1/2 power in the numerator. In the denominator, remember the exponent rules. 10 to the 1/2 power times 10 to the 1/2 power equals 10 to the 1st power. You add the exponents together. 10 to the 1st power is simply 10. We get our answer to be 7 times 10 to the 1/2 power over 10, which is essentially the same answer we got the first time we did it. Let's try another example. Let's say we have the fraction 7 over 12 to the 3/7 power. How do we rationalize the denominator? We need to get rid of the radical in the bottom. So let's try multiplying by 12 to the 3/7 power on the numerator and denominator. If we do that, we get 7 multiplied by 12 to the 3 over 7 power over 12 to the 6/7 power. Is this our answer? And the answer is no, this is not our answer, because there is still a radical in the denominator. 12 to the 6 over 7th power is a radical that is equal to 12 radical 7, the whole thing to the 6th power. This is not our answer. So what do? Well, we try to multiply by an exponent so that the exponent's power in the end is 1. So I'm going to show side work here. I will do 3 over 7, which is the power in the denominator, plus x equals 1. When you subtract by 3 over 7 on both sides, you will get x equals 4 over 7. Therefore, we multiply by 12 to the 4/7 power. In the numerator, we get 7 multiplied by 12 to the 4/7 power. Let's look at the denominator. The denominator is 12 to the 3/7 times 12 to the 4/7. This equals to 12 to the 7 over 7, which equals 1. Therefore, the denominator is 12 to the 1st power, or simply 12. Notice how we don't have a radical in the denominator anymore. The answer is 7 multiplied by 12 to the 4 over 7 over 12. This problem was meant to show you that you do not always multiply by whatever is in the denominator. For example, you shouldn't have multiplied by 12 to the 3/7 power in the numerator and denominator, just because it was the radical in the denominator of the problem. You had to think to figure out what you should multiply by to get rid of the radical in the denominator. Let's try another example. Let's say we have the fraction 12 to the 5 over 6th power divided by 20 to the 8 over 9th power. Before we start solving this problem, remember that you cannot cancel 12 and 20 since they are raised to different powers. So we have this problem. The first step is to figure out what to multiply the fraction by. Remember, the concept is to rationalize the denominator. If the numerator has a fraction exponent or has a radical, that is completely fine. However, the denominator should not. So, when figuring out what to multiply the fraction by, look at the denominator and only the denominator. The denominator is 20 to the 8 over 9th power. I will do 8 over 9th, which is the power in the denominator, plus x equals 1. When you subtract by 8 over 9 on both sides, you get x equals 1 over 9. Therefore, to make sure there is no radical in the denominator, I'm going to multiply the denominator by 20 to the 1/9 power. And whatever I do to the denominator, I have to do to the numerator as well, so that I retain the value of the problem. In the denominator, I get 20 to the 9 over 9th power, which is simply 20 to the 1st power, or 20. Let's look at the numerator. I can't simplify this any further since the two numbers do not have the same base. One number's base is 12, and the other number's base is 20. Therefore, the answer is 12 to the 5 over 6th power times 20 to the 1 over 9th power divided by 20. We have rationalized the denominator. Let's try another example. Let's say we have the fraction 10 over 15 to the 4 over 3 power. How do we rationalize the denominator? In this case, the numerator of the exponent, which is 4, is greater than the denominator of the exponent, which is 3. So let's try it the way we've been doing it throughout this video. I'll look at the exponent in the denominator, which is 4 over 3, and then I'll do plus x equals 1. When you subtract 4 over 3 on both sides, you get x equals negative 1 over 3. So I'm going to multiply the numerator and denominator by 15 to the negative 1 over 3 power. I get 10 times 15 to the negative 1 over 3 power over 15. However, there's a problem here. Remember our properties of exponents. This is equal to 10 over 15 times 15 to the 1 over 3rd power. We have a radical in the denominator. We did not rationalize it. So we did all that work and we came back to a circle. However, there is another way to do this. In the denominator, when the numerator of the exponent is greater than the denominator of the exponent, we split the exponent up. 15 to the 4 over 3 power, where 4 is in the numerator and is greater than 3, which is in the denominator, we can use properties of exponents to split it up to 15 to the 3 over 3 power times 15 to the 1 over 3 power. 15 to the 3 over 3 power is 15 to the 1st power. We want to split the exponents so that one exponent is equal to a whole number. In this case, one exponent is equal to 1. 15 to the 1st power is simply equal to 15. And we have a 15 to the 1 over 3 power as well in the denominator. Now, we are going to do the same thing we've been doing in this video. 1 over 3, which is an exponent in the denominator, plus x equals 1. And when you subtract by 1 over 3 on both sides, you get x equals 2 over 3. So we multiply the numerator and denominator by 15 to the 2 over 3 power. Then, in the numerator, we get 10 times 15 to the 2 over 3 power. In the denominator, we get 15 times 15 to the 1 over 3rd power times 15 to the 2 over 3rd power. 15 to the 1 over 3 times 15 to the 2 over 3 equals 15 to the 3 over 3, which equals 15. 15 times 15 is 225. Therefore, our final answer is 10 times 15 to the 2 over 3 divided by 225. Let's try one last problem. Let's say we have the fraction 2 over 11 to the 9 over 4 power. How do we rationalize the denominator? Remember, in the denominator, when the numerator of the exponent is greater than the denominator of the exponent, we split the exponent up. 11 to the 9 over 4 power, where 9 is the numerator and is greater than 4, which is in the denominator, we can use the properties of exponents to split it up to 11 to the 8 over 4 times 11 to the 1 over 4 power. 11 to the 8 over 4 power is 11 to the 2nd power. We want to split the exponent so that one exponent is equal to a whole number. In this case, one exponent is equal to 2. 11 to the 2nd power is 11 times 11, which is 121. And we have 11 to the 1 over 4 power as well in the denominator. Now, we are going to do the same thing we've been doing in this video. 1 over 4, which is the exponent in the denominator, plus x equals 1. And when you subtract by 1 over 4 on both sides, you get x equals 3 over 4. So we multiply the numerator and denominator by 11 to the 3 over 4 power. Then, in the numerator, we get 2 times 11 to the 3 over 4 power. And in the denominator, we get 121 times 11 to the 1 over 4 power times 11 to the 3 over 4 power. 11 to the 1 over 4 times 11 to the 3 over 4 equals 11 to the 4 over 4, which equals 11 to the 1st power, or simply 11. 121 times 11 equals 1,331.